Let's see a couple of examples applying the vector product. In the first one, we are given two vectors A and B, and we want to find the dot product and the cross product between those vectors. I'm gonna pause for you to do this and we'll look at the results. So here are the results that I got when I took the dot product between A and B. This is a number, the number -1. This is gonna be useful for part 2 because we have the formula that says that cosine of theta is equal to the dot product between A and B divided by the length of A times the length of B. And this is for theta, the angle between A and B. So we need to find what is the length of A and what is the length of B. So let's pause the video and do that. So we have that cosine of theta is equal to -1 in the numerator, and then in the denominator we have square root of 14 for the length of A times the square root of 2 for the length of B. We can write this as minus, and then we're going to have square root of 7 over 14. Now for the last part, we want to find the sign between the vectors A and B, and we're going to use the cross product between A and B. It's a new vector with coordinates 1, 5, 1. And then we need to find what is for that vector, what is the length of it. So we need to do that to be able to apply the formula. So then we're going to write that the sine of theta is equal to the length of that vector that we see how to find, divided by the length of A times the length of B, and that we already found is the square root of 28. So let's pause and do that. So we get for the length of the cross product square root of 27, and then for the length of in the denominator for the product of the length we have square root of 28. Let's write this as 2 square root of 7. So we can rationalize this fraction and write square root of 27 times square root of 7 over 14. If we wish to check our results, we would like to check that the sum of the squares of the cosine and the sine has to be equal to 1. So we can try that. The square of the cosine plus the square of the sine, we are going to get square root, denominator 14 square, and then we're going to have on the numerator 7 plus 7 times 27. This is 7 times 28 over 2 times 7 square, and this is actually 7 times 7 times 4 over 4 times 7 square, and this is equal to 1 as we wish to check. Notice that in this example we were given this formula for the length of the cross product between two vectors, relating it as to the sine of the angle between them. This is a very important formula, and it's what I was promising earlier in an earlier video when I was saying that we are also going to get a geometrical interpretation of what the length of the cross vector is. So that's a formula that was introduced in this example and you want to keep because it's very important. I wrote one more time this important property about the length of the cross product of A and B being the product of the lengths of A and B times the sine of the angle between A and B. And remember that we consider the angle between A and B to be an angle between 0 and 180 degrees, and we could include both of them. We need to use that to complete the second one of our examples. If we have A and B non-zero vectors, we wish to prove that their cross product is equal to 0 if and only if the vectors are parallel. So let's look at this. If we know that the vector product is equal to 0, then that means that the length of that vector is 0, but that gives us, applying our formula, that 0 has to be the same as the length of A times the length of B times the sine of theta. And the length of A is not 0, and the length of B is not 0, because those are non-zero vectors. So this implies that the sine of theta is equal to 0. And then this means that either theta is equal to 0 degrees or theta is equal to 180 degrees. And in both cases, this implies that our original vectors were parallel. So it's an exercise for you to check that we can reverse the arrows here and prove that if the vectors are parallel, then the cross product is going to be 0. And the last thing we want to do is to take a look at what's in the formula booklet about all these definitions and properties that we have been seeing in the last couple of videos. So let me scroll down a little bit. The first thing we want to look at is the formula related to the scalar product. This is what you have in the formula booklet. We have the definition, the direct definition. We have the property with the cosine of the angle theta, and we even have that with the cosine of the angle theta isolate. About the vector product, as promised, we have the definition. We have also this important property we were working with right now related to the sine of the angle between the vectors. And we have also one more property that we have not used yet, and it's about the length of the cross product of B and W being equal to the area of the parallelogram that have B and W as adjacent sides. So if we have V and we have another vector W, then they determine a parallelogram. Well, it doesn't look very parallel on my picture. The area of that parallelogram is the length of the cross product between V and W.